Welcome back to Solve It with Sir Jude. Today we will be discussing about joint and combined variations. This is actually the continuation of the video lesson that we had last time about direct and inverse variation. Ano nga ba ang pinagkaiba ni joint kay combined? And how are they related to the two previous kinds of variations, direct and inverse? Let us focus first our discussion on joint variation. So joint variation is somehow related to direct variation in a manner that we need to multiply. Okay? Joint variation deals with three or more quantities. The variation statement, example of this is A varies jointly as B and C. How are we going to translate this one in an equation? So we need to get the first quantity, which is A, is equal to the constant of variation K. What are we going to do with the remaining two quantities B and C? Sabi nga natin, parang direct variation siya, we need to multiply. So that will be A is equal to K times B times C. Okay? So K is still the constant of variation. So now let us have some exercises about translating the variation statements into equations. The first one, X varies jointly as Y and Z. So how are we going to translate this one? Get the first quantity, which is X, is equal to, of course, our constant of variation K. What are we going to do with the two remaining quantities? Since it is jointly or joint variation, we need to multiply them. So that will be Y times C. So therefore, if we are going to translate this one in an equation, that will result to X is equal to K times Y times Z. The second example, M varies jointly as the square of P and the cube of R. So in this example, meron ng condition na naka-include. So let us now translate. So the first quantity is M, so that will be M, is equal to, of course, our constant of variation K. So it is stated here square of P. So since it is square of P, so that will be K multiplied to P squared. And then the cube of R. So P squared multiplied by the cube of R, or simply R cubed. So if we are going to translate number 2, the correct translation into equation will be M is equal to K times P squared times R cubed. So let us now proceed to number 3. So the weight of an object W varies jointly as the mass of an object M and the acceleration G. So to translate this one, we need the first quantity, which is W. So write W. So we should take note na kapag capital ang gamit capital letter. If it is in lowercase din yung mga letter. So therefore, since we are using capital letter W here, we will be writing capital W is equal to K, the constant of variation, times the second quantity, the mass of an object, which is M, and then the acceleration, which is represented by G. So therefore, the final answer, the equation will be W is equal to K times M times G. So let us now solve some of the problems involving joint variation. The first example, suppose A varies jointly as B and C. If A equals 36, when B equals 3 and C equals 2, find A when B is equal to 7 and C is equal to 5. So just like what we did in direct and inverse variation, we will still be using the same steps. The first one, we need to translate the variation statement given by A varies jointly as B and C. So to translate this one, we have A is equal to K multiplied by B multiplied by C, since we are dealing with joint variation. Next, we need to solve for the constant of variation K. How are we going to do that? We will be using this statement. If A equals 36, when B equals 3 and C equals 2. Ito yung may mga given na values, yung mismong quantities na given for us to find the value of K. So from our original equation, A is equal to K BC, our translation, we just need to substitute the values of A, B, and C to this equation. So A equals 36, B equals 3, and C equals 2. Substituting, we have 36 is equal to K times 3 times 2. So 3 times 2 will be 6. 6 times K, that will be 6K. That is why we have 36 is equal to 6K. We only need the value of K. But in this one, we are given with the value of 6K. So we need to divide both sides of the equation by 6. So 36 divided by 6, that will be 6. 6K divided by 6, that will be K. So therefore, the value of K is equal to 6. So after getting the value of K, which is equal to 6, the next step is to rewrite the equation using the value of K obtained. So out of the given translation, A is equal to KBC, we just need to substitute the value of K, which is 6, to this translation. So it will become A is equal to 6, B times C. Next, the last step, we need to solve for the unknown. Ano nga ba yung unknown? We can find it using this phrase or this statement. Find A when B equals 7 and C equals 5. So we need to find the value of A when B is 7 and C is 5. Anong gagamitin natin equation? This equation in red ink. So that will be A is equal to 6BC. So we just need to substitute the values of A, B, and C. So the value of A is unknown, so therefore it will still be A. The value of B is 7, and then the value of C is 5. Upon substitution, that will become A is equal to 6 times 7 times 5. Multiplying 6, 7, and 5, the value of A now will be equal to 210. So therefore, A is 210 when B is equal to 7 and C equals 5. So let us now proceed to example number 2. This time, real-life example. The volume of a pyramid varies jointly as its height and the area of its base. A pyramid with a height of 12 feet and a base with area of 23 square feet has a volume of 92 cubic feet. Find the volume of a pyramid with a height of 17 feet and a base with an area of 27 square feet. So, kung titingnan natin, kung babasahin natin, parang mahirap sagutan. Pero ang una natin gagawin lagi is to translate. If you can see, walang mga variables na gamit. So, this is the time that you are going to assign variables to the quantities given. Ano ba yung mga quantities given? First is the volume of the pyramid. The second one is the height. And then the third one will be the area of its base. Karaniwang ginagamit or nire-represent ang isang quantity using the first letter of the quantity. Like for example, so let V be the volume. And then H for the height. And then A or capital A for the area of the base. So using this underlined statement, we will be translating them using our variables given. We have V, H, and A. Since varies jointly, we get the first variable, which is V, and that will be equal to K, our constant of variation, times the height, which is H, and then the area of its base, which is A. So therefore, the equation that will represent the problem will be V is equal to K times H times A. Next process, we need to solve for the constant of variation K. So we need our translation. And then, we will be using this statement, the height of 12 feet and a base with area of 23 square feet. The volume is 92 cubic feet. So to find the value of K, kailangan yung mga quantities na kukuhain natin muna will be given. So dito sa statement na to, given yung height, yung area ng base, at yung volume. So we can use this. Ayan, the volume is 92 cubic feet, the height is 12 feet, and A, or the area of the base, is 23 square feet. So we will be using V is equal to KH times A. So substituting the value of V is 92, H is 12, and then capital A is 23. So that will be 92 is equal to K times 12 times 23. We need to simplify K times 12 times 23, and that will become 92 is equal to 276K. Next, we only need the value of K. but we are given with the value of 276k. The next thing that we should do is to divide both sides of the equation by 276. 276k divided by 276 will be k. How about 92 over 276? If we are going to get the lowest term, both numerator and denominator are divisible by 92. Simplifying, we have k is equal to 1/3. So we already now have the value of k. What is the next step? The next step is to rewrite the equation using the value of k obtained. So, ito yung ating translation. We just need to substitute the value of k. K is 1/3, so therefore, the equation that we are going to use para ma-solve yung pinapahanap sa atin or the unknown will be v is equal to 1/3 times h times a. So let us now solve for the unknown. So that will be find the volume of the pyramid with a height of 17 feet and a base with an area of 27 square feet. So we should take note that we are looking for the volume of the pyramid, and we are given with the height, which is 17 feet, and the area of the base, which is 27 square feet. We just need to substitute these two quantities to our v is equal to 1/3 h times a. So h is 17 and a is 27. So that will become v is equal to 1/3 times 17 times 27. If we are going to multiply, take note that these two, 17 and 27, are whole numbers and they do have denominators of 1. So in multiplying fractions, we just need to multiply all the numerators followed by the product of the denominators. So 1 times 17 times 27 divided by 3. And that will become v is equal to 459 over 3. 459 is divisible by 3. 459 divided by 3 is simply 153. And since we are looking for the volume of the pyramid with a height of 17 feet and a base of 27 square feet is 153 cubic feet. So that is all about the joint variation. How about the combined variation? Combined variation is the combination of two variations. It is either direct and inverse, the two of them combined, or joint and inverse. Joining them, we have the combined variation. Let us have a variation statement that exhibit combined variation. So A varies directly as B and inversely as C. If you can see, we have here two involved variations, direct and inverse. So to rewrite this one, we have the first quantity A. So that will be A is equal to K, the constant of variation. So directly as B, we need to multiply B to K since it is direct. Then inversely as C, since inverse is division, we need to divide them by C. There. So remember, no, kapag direct, we need to multiply that quantity to the constant of variation. But when we are dealing with inverse, we need to divide the constant of variation by the second quantity. So still K is the constant of variation. So let us now proceed with translation. Translate the following variation statements. Number 1. C varies directly as D and inversely as F. So we need to get the first quantity, which is C, is equal to K. Again, the constant of variation directly as D. So therefore, we need to multiply D to our constant of variation. That is why we have K times D. And at the same time, inversely as F. So therefore, divided by F. So therefore, this statement has the equation C is equal to K times D over F. So number 2, M varies jointly as S and T, and inversely as the square of U. This time, we combine joint and inverse. So we get the first quantity, which is M, is equal to K, our constant of variation. Remember that when we are dealing with joint, we just need to multiply those quantities. So that will be S times T. And inversely as the square of U. Inversely, so therefore divided by, again, we have here condition square of U. So we have U Since it is square, we need to square u. So therefore, we have m is equal to k times s times t all over u squared. So let us now proceed to solving problems involving combined variations. Number 1, if y varies directly as x and inversely as z, and y is 12 when x is 10 and z is 5, find y when x is 7 and z is 2. So same process, we need to translate. Translate y varies directly as x and inversely as z. So that will become y is equal to kx, since directly as x, and inversely as z, that will be divided by z. Then after that, we need to solve for the constant of variation. So we are given with y equals 12 when x equals 10 and z equals 5. A matter of substitution for us to get the value of k. So we have y is 12, x is 10, and z is 5. Substitute. So we have 12 is equal to k times 10 over 5. K times 10 is 10k. 10k divided by 5 is 2k. So therefore, we have 12 is equal to 2k. We need to divide both sides of the equation by 2 for us to get the value of k. So 12 divided by 2 is 6. K divided by 2 will be k. So therefore, the constant of variation is k equals 6. So next, out of our translation and the value of k, we need to rewrite the equation using the value of k obtained. So a matter of substitution of the value of k to our translation, it will become y is equal to 6x over z. So the next one, we need to solve for the unknown. We will be using y equals 6x over z. And the statement, find y when x is 7 and z is 2. So a matter of substitution, to our equation, y is still y since it is unknown. We need to substitute x is 7 and z is 2, so that will become y is equal to 6 times 7 over 2. 6 times 7 is 42 over 2. 42 divided by 2 will become 21. So therefore, y is 21 when x is 7 and z is 2. So let us now proceed to the second example. The centripetal acceleration A of an object varies directly as the square of its velocity v and inversely to the radius r. So we are already given with the variables that we are going to use for representation. We have a, v, and r. So the centripetal acceleration of an object is 45 centimeters per square seconds, with a velocity of 6 centimeters per second and a radius of 4 centimeters. What is the centripetal acceleration if the velocity is 4 centimeters per second and the radius is 5 centimeters? So therefore, again, we need to translate. Centripetal acceleration A of an object varies directly as the square of velocity v and inversely proportional to the radius r. So that will become A is equal to kv squared, since A varies directly as the square of its velocity, so that will be kv squared, and inversely proportional to radius r, so that will be divided by r. So this will be our translation. A is equal to kv squared over r. So next, we need to solve for the constant of variation. So we will be using this statement for us to solve for the value of k. So again, we will be using our translation. So 45, since the acceleration or the centripetal acceleration of an object is 45, so substitute 45, is equal to k. How about the velocity? The velocity is 6 centimeter per second. So substitute, so that will become 6 squared. Then divided by the radius, which is given by 4 centimeters. We square 6 since we are given here with v squared. Okay? Then, we need to simplify. 6 squared is 6 times 6, 36. 36 times k will be 36k. 36k divided by 4 will be 9k. So therefore, we are given now with 45 is equal to 9k. We only need the value of k, so therefore there is a need for us to divide both sides of the equation by 9. 45 divided by 9 is 5. 9k over 9 is k. So therefore, the value of k is equal to 5. So next, out of our given translation and value of k, we need to rewrite the equation using the value of k obtained. So a matter of substitution, so the new equation will be a is equal to 5b squared over r. So this equation now will be used for us to get the unknown. The last process, solve for the unknown. So what is the centripetal acceleration if the velocity is 4 centimeters per second and radius is 5 centimeters? So we are to find the value of a, or the acceleration, when the velocity is 4 and the radius is 5 centimeters. Matter of substitution, so a is still missing, so that will be a is equal to 5, the value of b is 4, so that will be 4 squared over 5, which is the value of r. Then, that will be 5 times 16 over 5. Why is it 16? 4 squared, 4 times 4, that will be 16. Next, 5 times 16 will now be equal to 80 divided by 5. 80 divided by 5 will now be a is equal to 16. So therefore, the centripetal acceleration of the object is 16 centimeter per square second given the velocity 4 centimeter per second and the radius 5 centimeter. So we are now through discussing joint and combined variation. I hope that you've learned something for today, specifically about joint and combined variation. So next time we will be dealing with exponents. So this is the continuation of your lesson during your past level or grade level. So if you are new here in our channel, please don't forget to subscribe, like the video, and hit the notification bell for more video lessons. So this is Sir Jude. Good day.